All right, class.
Yes. Yeah.
Y'all weak. Okay, let's try it one more time. Class.
Yes.
Okay, that's better. So, now that I have your attention, we are going to do this. This is actually pretty easy. It goes along with the spanning trees of what we had on the previous lesson. Spanning trees mean that we are going to connect each one of these. So I'll pull up the notes because a lot of people just wrote those down and didn't actually do anything. Okay. Is there a unique one path between every vertices? Does that make sense? Okay, I'll explain that here in a minute when I finish. Is it connected, and is every edge a bridge? So by connected means, is there a way, is there a road? So when we were doing this previously, we would refer to every dot as one of the houses, right? Yeah? And all the lines connecting are roads, right? So by being connected means every house has a road going to it. And there I can go to any house from any other house. There is roads going from one to the other. There is a pathway for me to go. There is a road for me to go from one to the next, right? Okay. So for instance, we have, we're trying to go over to Joe's house, right? Okay, Fred's trying to go over to Joe's house, and he needs to have a road to go from your house to his house. Yeah, that's connected. Now, connected every edge of bridge doesn't have n vertices, n minus 1. That was this meaning. Oh, dang it. That's as 4 minus 1 is. So, vertices means the houses, the points, and the edges. The minimum number of edges connecting all these trees would be 3. So if you notice right here, there was 3 here, 3 here, 3 here, 3 here. Yes. Now, zero circuits, I redid the definition for zero circuits, and I said zero circuits mean no circuits. That's what that means, zero circuits. It means no circuits. That means a circuit is, I could actually go around in a circle. So if it was directional, I could keep going. I wouldn't have to stop and turn around to go back. So a circuit, I will explain it here in a moment when we get on this next one. And you can lift up your pencil and only use existing roads. Okay, I know Fred likes to drive crazy, but he has to stay on the road, right? If he's going to your house, your mom would be kind of mad if he just drives through the backyard, right? Yeah, so that's how Fred normally drives, though. But still, he cannot do that. All right, so going back to the notes. Okay, suppose you want to supply a house, set of houses, say in a new subdivision with electricity, water, sewage, telephone lines. Keep costs down. You could connect the houses with a spanning tree, for example, power lines. However, since the houses are not all equal distance apart to reduce even further costs, you could connect the house with a minimum cost spanning tree. And that's what we're doing today. So we're doing spanning tree, but we are trying to get to a minimum spanning tree. Why does it not line up? Why is it got to be weird? There we go. So if you have a connected, undirected graph, connected means all points are connected. Undirected means you don't have any one-way streets. All the streets are bidirectional, so you can go either way with those. And graph with a weight at cost associated with each edge cost of a spanning tree would be the sum of the cost of its edges. So minimum cost spanning tree is a spanning tree that has the lowest cost possible. Now, first thing I'm going to do, how many vertices or how many houses do I have here?
6.
There's 6. 6 vertices. So I would say it would be 6 vertices or 6 houses in my analogy, because I keep using houses as this, because if we're connecting houses, it usually makes more sense. So what would be the minimum number of roads or bridges or edges we're going to have to use?
5.
5 because my formula was on the previous was 6 minus 1 is going to be 5 edges. Does that make sense now? So that's what I was explaining previously. That's how many edges I would actually have. Now, we're going to go through and look at it to show a minimum cost spanning tree. So this is with an example of all the roads I have. So when I'm doing this, what roads do I want to use? What roads do I want to use? The smallest ones, right? And I want to avoid using the larger ones, right? So let's see. So I know I want to use the 6, the 5. I don't want to use the 10, right? If I use a 10, what would that do? It would make it a circle, right? That would be a circuit. So I would not use that. Which one do I want to use now? Okay, so I want to go to here, right? Now, I don't have to actually just keep going from there. This is the part what I was talking about. I can pick up my pencil, right? I can pick up my pencil. So I don't have to go from D over this way. I can go with the next one, right? So if I have to go that way, that means everything else is more expensive, and then I would have to make a circuit to go there. So I'm going to back this up, and that's where it sees right here. I'm going to use the 11. Now the next one I would use would be the 16. So I'm picking up, going to 16, using that one. Again, picking up, using the 18 because that's the cheapest to go from any of these over to E. That's how that one was made. By looking at it item by item, we could actually pick and choose the roads that we want to have. Does that make sense? So now I can go from Fred's house with F over to Joe's house with an E. Yeah, Joe gets an E. So from Fred to Joe, there is a road to go there. He has to go to B to D, then over to E. So they're all connected. There's all roads connecting from one to the other. There is no circuits on here. And the minimum that I would have. So what would be the minimum of this spanning tree? How do you think I could figure out the minimum?
You added it to the track what?
Oh, no, that's the edges. You had it?
You add them.
Yes, we add them up. The minimum for this whole spanning tree, not the number of edges, okay, that's what we're going for. So the minimum for this, so minimum cost, that's what I'm looking for. So add all those up. So add those up, see what we get. Two.
What's the magic word? And 96. 47.
Let me see. This is 40, 56?
Yeah,
56? Just double check because I'm kind of doing stuff in my head.
I double checked in my head.
Okay. You guys agree? 56? Okay. So my cost is going to be 56, whatever my units are, and lowest cost would be dollars or millions or hundreds of thousands or whatever it actually costs. Right? Okay, good, thank you. All right, so the next one. Next one, so let's go up to this one here. I am not even going to come close on trying to figure out how to pronounce his name. Cusco? There it is, Cusco. Is it coming along? Isn't that his thing? It's coming along. Cusco? Cusco? I don't know. Anyway, Okay. Kuzco's algorithm tells us to add the edges of a graph in order of increasing cost but avoid circuits. Start with none of the edges being part of the solution. That's what we're doing down here. Add edges one at a time, starting with the cheapest edge, but don't add an edge if it would create a circuit. Keep adding until every vertex is connected to the network. All right, so I'm going to zoom in a little bit more on this to make this easier. There we go. Okay. So what would be the first one I should use? AB. That sounds good. Yes. Are you guys following along, or just everyone's still asleep? Hopefully we're getting there. What would be the next one I should use? B to C. That's a good one. A to what?
D.
A to D?
Yeah.
BE? D to F? Is that what you said?
Yeah.
DF? Anyone else? What if I tell you we have a test on this in like next week?
Oh.
So you might want to start participating, right? And not having earbuds in and trying not to listen to me, right? Because earbuds in, it's kind of annoying, especially if you're a teacher. It just sounds like, it looks like you're trying to ignore me.
What are we doing? We're trying to connect it?
Oh, yes, yes. So we're making a spanning tree on this. And we're putting away our earbuds, ear pods, ear biscuits, all that. You're putting those away, right?
D.
What to D?
What?
Say,
D, G. No, there's no.
what's the next one?
D to G.
D to G, thank you.
You said D to H. I said D to G. You said D to H.
There's no road from D to H.
E to H. Can't you go E to H?
E to H?
Yeah.
We could. Does that connect everything? They're all connected, right? So I can go from F all the way to H with no problem? Any circuits?
No.
No circuits. So let's see, what would my path be then? So the cost would be, let me see, we have 1, 2, that is 3, 6, plus that is 13, and then we have 8, which is 21, and then we have 5, which is 26, and then we have to H, which is
37.
yeah. I don't see another way to actually make it any cheaper. Questions, concerns, complaints? So if you guys want more homework, everyone stay quiet.
Yeah, I get more trouble. I got it.
Kinda. A lot of people actually sounds like you want more homework.
Yeah, those people. Yeah.
There we go. And all right, going back to this. Guess what? That's it. That's it for the notes. Now let's look at what the homework has.
We should do that in middle school. Mister, are we doing 5.1 or 5.2 homework?
It should be 5.2. Dang it. Okay, I'm gonna pause it real quick. All right, there we go. So here's homework. Now, let's pretend like I paid attention earlier at the beginning of class. What page is my homework going to end up on?
Left side.
Number
7.
6. The notes are always on the right side. The homework's on the left. All right? Notes are on the right, homework's on the left. So this will be on page number 6. And then my previous one here will be on page number 7. So looking at the worksheet, that's all we're doing. Go through, figure it out, and then total it up. Make sure there are no circuits. Does anyone have questions over this? No? Let's look at the next page. Look, it's a word problem with the exact same thing. This time it gives you a whole thing where we're actually trying to figure out cable, I think it says. Network cable, yeah. Same thing here for each one, but this one actually gives you this graph. Okay, this gives you a table, and I recommend make a graph first. So actually draw what it's going to look like. We have 1, 2, 3, 4, 5. Is that what we have? We have 5. Yeah, we have 5 vertices. So you need to put 5 vertices here and start drawing it out. Make a weighted. Make it look like number 7. And then you can answer the questions. All right, any other question from there? All right, don't forget, like, share, and subscribe. Hit that notification button. And what else? Oh, buy stuff at my merch store. Buy my stuff. Make me rich.